Hello guys, and welcome back to this channel. In today's video we are going to solve likely examinable questions on elective mathematics. Now these set of questions are likely to appear in this year's Wassce, and so you would like to take this set of questions very serious. So if you are new here, consider subscribing to this channel. Do well to like this video and share this video to your friends. So in our first question, we are going to find dy dx if x cubed plus 2xy plus y squared is equal to 8. X cubed plus 2xy plus y squared is equal to 8. We are going to find dy dx. Now this is an implicit function, and for implicit functions, what we are going to do is we are going to differentiate term by term with respect to x. So what happens is when you differentiate an x term, you do it as the normal differentiation that we know. However, when you differentiate a y term, then you want to multiply by dy dx. So let's solve this together. So we have the function x cubed plus 2xy plus y squared equals 8. So first of all, we are going to differentiate term by term, starting from x cubed. So when you differentiate x cubed with respect to x, you have 3x squared. Now this is 2xy, so we are going to factor out 2. And then we solve xy using the product rule. So according to the product rule, we maintain one value and then we differentiate the other, plus this time we maintain the other value and then we differentiate the first value. So we are going to maintain the x value and then differentiate the y value or the y term. Now when you differentiate y, you have 1, and then because it is y we are differentiating, we are going to multiply by dy dx. So we have dy dx plus this time we maintain y, and then we differentiate x. Now when you differentiate x, you have 1. So that is that. And then for y squared, when you differentiate y squared, you have 2y, and because it is y you are differentiating, you want to multiply by dy dx. Now when you differentiate 8, which is a constant, it goes to 0. So now let's simplify this expression. So you have 3x squared plus 2x times dy dx plus 2y plus 2y dy dx equals 0. Now because we want to find dy dx, let's group the terms containing dy dx on one side. So we have 2x dy dx plus 2y dy dx, and then we transpose 2y and then 3x squared to the right hand side. So that becomes negative 3x squared minus 2y. So we have dy dx on the outside, and then inside the bracket we have 2x plus 2y, and that is equal to, now we can factor out a negative 1, so it becomes negative 1, and then we have 3x squared plus 2y. Now because we are interested in finding dy dx, we can divide through by 2x plus 2y, so that we have dy dx equals negative 1 times 3x squared plus 2y divided by 2 times, and even here we can factor out 2 so that we have x plus y inside the brackets. So dy dx is equal to negative 1 into bracket 3x squared plus 2y divided by 2 into bracket x plus y. So this is how to solve implicit functions. Let's move on to our second question. So in our second question, we are going to resolve the partial fraction x squared over x minus 2 times x minus 3. We are going to resolve this partial fraction. Now, this is an improper partial fraction in the sense that the degree of x in the numerator is the same as the degree of x in the denominator, especially when you multiply this factor by this factor. So when you multiply x by x, you have x squared. So the degree of x in the numerator is the same as the degree of x in the denominator. So this makes that an improper partial fraction. So we need to resolve this as a proper partial fraction before we can work on that. So let's do that together. So this is x squared divided by x minus 2 times x minus 3. Now let's simplify the denominator. Now x times x is x squared. X times negative 3 is negative 3x. Negative 2 times x is negative 2x. So negative 2x minus 3x is negative 5x. And then negative 2 times negative 3 is plus 6. Now we are going to divide x squared by x squared minus 5x plus 6. So we are going to have x squared minus 5x plus 6 on the outside, and then we have x squared inside of the square root. Now this is the same as x squared plus 0x plus 0. Okay, so x squared divided by x squared is 1. So we have 1 times x squared, which is x squared. We have 1 times negative 5x, which is negative 5x, and then 1 times 6, which is 6. Now x squared minus x squared goes to 0. We have 0x minus negative 5x, which is plus 5x, and then 0 minus 6 is negative 6. Okay, so we say that x squared over x minus 2 x minus 3 is now equal to 1 plus, that is the quotient, plus 5x minus 6, which is the remainder, divided by the divisor, x squared minus 5x plus 6. Now in place of x squared minus 5x plus 6, we can simply write x minus 2, x minus 3, which are the factors. Now we've been able to resolve the improper partial fraction in the proper form. So we are going to deal with 5x minus 6 over x minus 2 times x minus 3. So we have 5x minus 6 divided by x minus 2, x minus 3. Now since the denominators have linear factors, we are going to expand this as a over x minus 2 plus b over x minus 3. So now let's find the LCM. The LCM is x minus 2 and then x minus 3. So we divide x minus 2, x minus 3 by x minus 2. X minus 2 cancels out x minus 2. We are left with x minus 3. So we have a times x minus 3, and then x minus 3 cancels out x minus 3. We have x minus 2 times b. So that is equal to 5x minus 6 over x minus 2 times x minus 3. Now because the denominators are the same, we only focus on the numerators. So we have 5x minus 6, that is equal to a times x minus 3 plus b times x minus 2. Next, what we are going to do is we are going to find the values of a and then b. So put x equals 3. Now if x is equal to 3, it means that the variable a goes to 0, and then we can find the value of b. Later we are going to put x is equal to 2 so that the variable b also goes away. Then we can find the value of a. So when x is equal to 3, we have 5 times 3 minus 6 equals a times 3 minus 3 plus b times 3 minus 2. 5 times 3 is 15 minus 6 is 9. So we have 9 equals, this goes to 0. 3 minus 2 is 1. So we have b equals 9. Now if we put x equals 2, then we have 5 times 2 minus 6 equals a times 2 minus 3 plus b times 2 minus 2. Now 5 times 2 is 10 minus 6 is 4. So we have 4 equals 2 minus 1 is negative 1, so that is negative a. So a is equal to negative 4. So we have the value of a to be negative 4. We have the value of b to be 9. So in that sense, 5x minus 6 divided by x minus 2, x minus 3 is equal to negative 4 over x minus 2 plus 9 over x minus 3. Now don't forget that the improper partial fraction x squared divided by x minus 2 x minus 3 was equal to 1 plus 5x minus 6 over x minus 2 x minus 3. So if 5x minus 6 over x minus 2 x minus 3 is equal to this, then we say that this is equal to 1 plus negative 4 over x minus 2 plus 9 over x minus 3. Hence, we've been able to resolve this improper partial fraction as a proper partial fraction. So now let's move on to the third question for today. The first, the fifth, and the 10th terms of a linear sequence are in geometric progression. Now, if the sum of the second and the 8th terms of the linear sequence is 30, then we are going to find I, the first term, and then I, we are going to find the non-zero common difference of the linear sequence. Okay, so we are told that the first, fifth, and the 10th terms of the linear sequence are in geometric progression. Now let's write down the first, the fifth, and the 10th terms of this linear sequence. Now we know that the general term of a linear sequence is given as un equals a plus n minus 1 times d, where a is the first term, d is the common difference, and then n is the number of terms. So if you want to find the first term, then this becomes u1 equals a plus 1 minus 1 times d. Because we are finding the first term, we say that n is equal to 1. So u1 is equal to, this goes to 0, 1 minus 1 is 0 times d is 0. So we are left with a. So u1 is equal to a. Now let's find for u5, or the fifth term. So u5 is equal to a plus 5 minus 1 times d, which is equal to a plus 4d. We also have u10, and I think you can guess the trend. That is going to be a plus 9d. Okay, now we are told that the linear sequence are in geometric progression. So let's write down the sequence. So it means that we have a, which is the first term in the geometric progression. We have u5, which is supposed to be the second term in the geometric progression, but the fifth term in the linear sequence. So that is a plus 4d. And also we have the 10th term of the linear sequence, that is a plus 9d, which happens to be the third term in the geometric progression. Now from the question, we are told that if the sum of the second and the 8th terms of the linear sequence is 30, then we are going to find I and II. So the second term is u2, and that is going to be a plus 2 minus 1 times d, which is equal to a plus d. And then also we have u8, which is equal to a plus 8 minus 1 times d, that is a plus 7d. So this is u2 and then u8. We are told that the sum of the two is equal to 30. So we have u8, or better still, u2 plus u8 equals 30. u2 is a plus d, and then u8 is a plus 7d. So we have a plus a, which is 2a, and then d plus 7d, which is 8d, equals 30. Now we can divide through by 2, so that we have a plus 4d equals 15. Let's call this equation 1. Now in linear sequence, we talk about the common difference, whereas in the geometric progression, we talk about the common ratio. Now the common ratio R is equal to u3 divided by u2, which is equal to u2 divided by u1. So we are going to apply this here. So u3 is going to be a plus 9d. So we have a plus 9d divided by u2, which is a plus 4d. That is equal to u2, which is a plus 4d, divided by a. Now we are going to do this because for the common ratio, you need to find the ratio between any two successive terms. So u3 divided by u2 should be equal to u2 divided by u1. So we are going to work on this. We are going to cross multiply. Okay, so we had a plus 9d divided by a plus 4d equals a plus 4d divided by a. So we are going to cross multiply. So we have a times a plus 9d equals a plus 4d times a plus 4d. So now let's multiply across. So we have a times a, this is a square, this is 9ad equals, we multiply a and a, so this is a square, we multiply a and then 4d, and then we multiply 4d and a. So a times 4d is 4ad times 2 is 8ad, and then 4d times 4d is 16d square. Now we have a square, we have a square, so we can cancel out a square, and then now we are left with 9ad equals 8ad plus 16d square. So now let's transpose all the terms on the right hand side to the left hand side. So we have 9ad minus 8AD minus 16D square equals 0. So this is AD minus 16D square equals 0. Now let's call this equation 2. Now let's keep in mind of this equation. We are going to come back to this equation. So we had equation 1 to be A plus 4D equals 15. That was equation 1. And then equation 2 is AD minus 16D square equals 0. So now let's make A the subject from equation 2. So from equation 2, AD is equal to 16D square. We divide through by D, and then we have A to be equal to 16D. Let's call this equation 3. Now we are going to put equation 3 into equation 1. So equation 1 is A plus 4D equals 15. So this becomes 16D plus 4D equals 15. We have 20D equals 15. We divide through by 20. And then we have the value of D to be 3/4. So this is the value of D. Now we are interested in finding the value of A, which is the first term. So still from equation 3, A is equal to 16D, and then we have D to be 3/4. So 4 goes into itself once, into 16 4 times, and then 4 times 3 is 12. So we have the first term to be 12. So for II, the second one, we are supposed to find the non-zero common difference of the linear sequence. We are going to find the non-zero common difference of the linear sequence. Now back to this equation, equation 2. We had AD minus 16D square equals 0. Now let's factor out D. So we have D outside. We have A minus 16D equals 0. So we have D equals 0. We have A minus 16D equals 0. Now we know that the value of A is 12. Okay. So this is 12 minus 16D equals 0. So let's transpose negative 16D to the right hand side. So that becomes 12 equals 16D. We divide through by 16. And then we have the value of D to be 3/4. So this is the non-zero common difference of the linear sequence. D is equal to 3/4.